Okay, so in this tutorial, we are going to discuss the question based on limit. Okay, so all the questions are from the test cells itself. So we are going to discuss this one by one. So in the limit, there are only two possibilities to ask the question. First is based on whether limit exists or not. So whether limit exists or not. Only though only this thing you have to check. But otherwise, the question will be based on find out the limit, right? Find the limit. And this will be based on mostly L hospital rule, right? L hospital rule. Only these two type of question has been asked. Like these are the two important concept in the limit. Like all the questions can be solved based on these two important concepts only, right? So they may give the value of a limit, find out the value of A and B. So that type of question also they can ask, but these two are the primary type of question they usually ask in the GATE exam. Okay, now let's try to solve this particular question. Now, if you like, so first thing we have to do is just try to put this value in this particular function. Okay, that's it. Okay, so limit x tends to 0 and this function is given to us. Just try to put this 0 in instead of x and see what we are getting. So this step you have to follow for solving each and every question. Okay, so if I just put 0 in instead of x, what I will get? 0 e to the power 0 plus 1 plus 2 cos of 0 minus 1. So 0 into any number will be 0. So it will be 0 plus cos 0 will be 1. So 1 minus 1, that will be 0. It is 0 by 0 form, right? So L hospital rule is applied to 0 by 0 form or infinity by infinity form. Okay. Now here 0 by 0 form is applicable. So what we have to do in this particular rule, just take the derivative of numerator and denominator separately. Okay. So for example, we have limit x tend to a, right? And we have numerator and denominator. Take the derivative of numerator separately with respect to x and take the derivative of denominator separately with respect to x. Okay. We don't have to apply the quotient rule here. We have to take the derivative separately for both numerator and denominator. Okay. Quotient rule is different. Okay. So please remember this point. Now just take the derivative. So you should know how to find out the derivative of a given function. Okay. So in this case, you can see u and v. So what I can do, just consider this, right? So derivative of first function, that is x derivative is 1 into x to the power minus 1 plus x into e to the power x plus twice of what is cos derivative, that is minus sign. It's minus sign of x, right? Divided by, just put derivative of x into again the uv function, right? We have again this uv rule we have to apply. So 1 minus cos x plus x into derivative of cos x is basically minus x. So minus minus will get plus. So that is minus sin x. Right now, just try to put limit x tends to 0. Right, just try to put x equals to 0. In this case, what will happen? E to the power 0, 1 minus 1 0 plus 0 sin 0 0. This also cos 0 1, 1 minus 1 0 plus 0. So again, we are getting 0 by 0 form. So just try to simplify this, and again we have to apply the L hospital rule. Just take the derivative. Okay. So but first we can simplify this equation, right? So e to the power x minus 1 plus x e to the power x minus 2 sin x, right? And this will be 1 minus cos x plus x sin x, right? Now just take the derivative of again numerator and denominator separately. What you are getting? So e to the power x derivative is e to the power x minus 1 derivative, that is constant, so 0. Again x into e to the power x plus derivative of x is e to the power x into 1, right? That's just derivative of this minus 2 into cos of x. So you should know how to find out the derivative, right? There is no shortcut for that. Again, derivative of cos x is minus sin x, so minus minus sin x. Okay, plus x into sin x, so x into cos x, the derivative of sin x plus x, that is basically sin x, right? Now, if we again try to put x equals to 0 here, so what we are getting? 1, okay, plus 0, right? Then e to the power x is again e to the power 0 is again 1, right? Minus 2 cos of cos 0 is 1, so that is minus 2. Again, sin 0 is 0, x is 0, and sin 0 is 0. So again, we are getting what we are getting here, that is basically 0 by 0, right? So again, we need to apply the L-Hospital rule here. So I'm just continuing here. Okay. So it will be e to the power x plus again x into e to the power x. So basically x into e to the power x in plus e to the power x. Now derivative of this e to the power x minus 2. What is the derivative of cos x? That is basically sin x minus minus will get plus. So minus sin x. Okay. So then what is the derivative of sin x? That is cos x. Derivative of x into cos x. So cos x plus x into minus sin x plus derivative of sin x, that is basically cos x, right? Now limit x tends to 0. Again try to put x equals to 0. What we are getting? So 1 plus 0 plus 1 uh, plus 1, right? 0. Again cos 0. So cos 0 plus cos 0 plus 0 plus cos 0. So here we are getting 3 upon 3, that is basically a 1, right? So answer will be 1. Okay, so here we have to apply 1, 2, 3, right? 3 times we have to take the derivative of a particular numerator and denominator respectively until we get this particular value. Okay, so if we are getting 0 by 0 form in every time, so every time we have to apply this L-Hospital rule, means take the derivative of numerator and denominator separately. So this is how we solve this particular question. So first thing is that you should know how to find out the derivative. This is very important part. So I have given the standard derivative. That PDF is there in the notes, so you can just go to it. You can just go through it. So it will be better to revise the standard derivative first. Okay. So yeah. So it just a derivative how well you know. So that's it from this particular question. The answer will be 1. I hope you understand this particular concept. Like every time we get 0 by 0 form, we need to apply L-Hospital rule. That is, need to take the derivative of numerator and denominator separately. Okay, now let's try to solve this question number 2, right? So limit x tends to infinity, 1 by sin x minus 1 by tan x, right? So first thing is that just try to put the limit and see what we are getting. So if I try to put the limit, we will get 1 upon sin infinity minus 1 by tan infinity, right? So this does not exist, trigonometric function. So whenever the limit x tends to infinity, always try to convert this expression into 1 by x form. Okay, because 1 by x is basically, if 1 by infinity is basically 0, right? So 0 is a valid limit, right? So whenever x tends to infinity, always try to convert the f of x into f of 1 by x by just taking the highest power common from the equation, right? So that is general for f of x, that is in polynomial thing you can do, but here it is trigonometric function. Now in this case also always try to simplify this equation first. So how we can simplify this? So limit x tends to infinity, right? So 1 upon 1 by sin x minus tan x is basically sin x upon cos x, right? So sin x upon cos x, right? Now what I can write, limit x tends to infinity, again 1 minus cos x 1 sin x, right? Now again here we need to apply the formula. So if you know we have 1 minus cos x is basically 2 sin square x by 2, so half angle formula. Okay, similarly sin x is basically 2 into sine of x by 2 into cos of x by 2, right? Half angle formula. So if you remember, so it is sine 2x. Sine 2x is basically 2 into sine x into cos x, right? Same thing we are applying here also, right? So what will, if I put this thing, what will we will get? So what we will get, 2 sine square x by 2 upon 2 sin x by 2 into cos x by 2, right? So this 2 will get cancelled, sin x by 2, this square will get cancelled, sin x by 2 into cos x by 2, basically a tan x by 2, right? So limit x tends to infinity, tan of x by 2. So if I put infinity here, so I will get tan of infinity. So what is tan of infinity? Is basically infinity only, right? So answer will be infinity. Okay, so this is question number 3, right? Now same here, that is x tends to infinity, right? But here we can see we have x cube and x square. So what I said earlier, just try to bring 1 by x form. Okay, try to convert this f of x into 1 upon x form. So if I want to convert this 1 by x into 1 upon if I want to convert this into 1 by x form, So what I need to do? So just take the x square common and x cube common from the numerator. Okay. Take the highest power common. So in this case, it's x cube. Okay. So it is x cube. So it will be 1 minus cos x cube, right? And here from x square, so x square common, 1 plus sine of x upon x square, right? Now we are x square and this will get cancelled, right? So what we are getting? X into 1 minus cos x cube upon 1 plus sine x upon x square, right? Now just try to put the limit. Okay. So limit x tends to infinity to the numerator. So x 1 minus cos of x upon x cube, right? We can do like this also, and limit x tends to infinity 1 plus sine of x by x square, right? But if you remember, limit x tends to infinity sine x upon x is basically a 0. Okay. And limit x tends to 0 sine by x upon x is basically a 1. Okay, but this is 0. So if I just transfer this limit to this particular sine x by x, so that will be a 0, right? So what I will get at the last, just put x tends to infinity. So instead of x, infinity, right? So numerator will be infinity and denominator will be 1 plus this limit x tends to infinity this sine x by x whole square. So what I will get? Infinity upon 1 plus 0. That is basically infinity only. So the answer will be infinity. Okay. So this is simple. So please try to remember that this whenever x tends to infinity, we always try to convert this into this equation, that is 1 by x form. So it means just take the highest power of the x as a common from both numerator and denominator and just try to convert this equation in this particular form, right? Then only you can apply this one by then only you will be able to solve such type of questions. Okay, that is x tends to infinity. Okay, so next question. So simple thing, limit x tends to 1 x square minus 1 divided by x minus 1. So this question number 3, sorry 4, right? So just if I put 1 1 here, so what I will get? 1 minus 1, 1 minus 1, 1, that is basically 0 by 0, right? So just apply L'Hospital rule. So limit x tends to 1, derivative of x square minus 1, that is twice x, divided by x minus 1, that is basically 1. So 2x into, just put the value of x here, that is 2. So answer will be 2. Simple. Okay. Just apply L'Hospital rule. That's it. Or also you can, what you can do in this case. So x square minus 1 square also, that is x minus 1. So you can simplify that. That is x plus 1 and x minus 1. Here also x minus 1. So x minus 1, x minus will get cancelled as x plus 1. So limit x tends to 1, x plus 1 will be 2 only, right? So that's it. Now what about this particular question? So if f of x is given to us, then limit x tends to 3 f of x, right? Now just try to put the x tends to 3 here. Okay. So limit x tends to 3. Just try to put 3 here. What we are getting? 2 into 3 square minus 7 into 3 plus 3 divided by 5 into 3 square minus 12 into 3 minus 9. So what I am getting? 2 nines are 18 minus 21 plus 3. And here 9 fives are 45 minus 36 minus 9. So that is 45, right? So 45 minus 45 0, 18 21 21 0, 0 by 0 form. Then just apply L'Hospital rule. That's it. So take the derivative of a numerator. So what will be 4x minus 7, and here 10x minus 12. Again limit x tends to 3. So limit x tends to 3, 4x minus 7 and 10x minus 12. Just try to put the limit. So 4 into 3 minus 7 and 10 into 3 minus 12. So 12 minus 7 and 13 minus 12, right? So that will be 5 by 18. Right, so option will be C. Okay, correct option C. So nothing in it, just we have to apply a hospital rule, and we should know the derivative. So the concept of derivative, how to find the derivative of a function is very very important in this case. Otherwise, it will be difficult to solve the limit question. Okay. So first, please remember the standard derivative. I have already shared the PDF file. Okay. So you can just go through it. Okay. Now, question number 6. So limit x tends to 0. This is given to us. Just put x equals to 0 at the limit. So see what we are getting. 0 minus 1 plus 0 plus 0. Okay. And then 0. So e to the power 0 is 1. So 1 minus 1 is 0. So it is 0 by 0 form. Just take the derivative. E to the power x minus 1 derivative is 0. X derivative is 1. Plus x square by 2 derivative is 2x by 2. Right. And here 3x square. So it will be, just simplify this, e to the power x minus 1 minus x, right? And here 3x square. Now just put the limit x tends to 0. What we are getting? 0, e to the power 0 minus 1 minus 0, again 0. So again 0 by 0 form. Differentiate again, what we are getting? The limit x tends to 0, e to the power x, derivatives e to the power x minus derivative 0 minus x minus 1. So again it is 6x, right? So again, if I try to put 0, again e to the power 0 minus 1 upon 0, that is 0 by 0 form. Again, take the derivative, what you are getting? E to the power x, and here 6, that is limit x tends to 0. So if I extract e to the power 0 divided by 6, that is 1 by 6 is the answer. Okay. So I'm doing this calculation fast so that you should know how to do the calculation faster during the GATE exam, right? So it's not like that. This question is easy, so you need to spend a lot of time. Within 1 or 2 minutes, you can solve this type of question, okay? But you should know how to find out the derivative of each and every function. This is very important. Otherwise, nothing in that question. You just need to take the derivative and put the limit, okay? But important thing is the derivative. Okay, so please practice for that. Otherwise, you can solve this question within 2 minutes. Okay. Now, question number 7. Like most of the question are based on the L hospital rule only. That's it. Okay. So if I try to just put limit x tends to 8 and this function, so what we are getting? 8 1 by 3 minus 2. So 8 minus 8 will be 0. Again 2 minus 2 will be 0. So 0 by 0 form. Simply take the derivative. That's it. So 1 by 3 x to the power minus. So 1 by 3 minus 1, that will be minus 2 by 3. Okay. And again 1. So if I just put x here, that is 8. So what I am getting? 1 by 3, 8 to the power minus 2 by 3. Right. So basically 1 by 3 into 8 to the power 2 by 3. Right. So first 1 by 3 is basically a 2. So 2 to the power 2, that is basically a 1 by 12. So 1 by 12 is the correct answer. Okay. Okay. Now question number 8. So similar type of question is there. Just try to put the limit and what we are getting? 0 by 0 form. Again limit x tends to 0. Take the derivative of numerator and denominator. So 3x square plus 2x. Again take the derivative of denominator. So 6x square, right, minus 14x, right. So again it is 0 by 0 form. Again take the derivative, limit x tends to 0. So 6x plus 2, here 12x minus 14. Okay. Again try to put 0. So what you are getting? 6 into 0, that is 0. 2 by minus 14, that is basically a minus 1 by 7. So answer will be option C. Simple. Within 1 minute you can solve this question, right? Okay. So this is question number 9. Okay. So what is the value of this particular limit? Now here limit n tends to infinity, and this is a function. Okay. So if you remember, if you have gone to the notes, we have one property, right? So limit x tends to infinity 1 plus e by x to the power x, that is basically e to the power a. So we have this particular property, right? So you can just check the notes. We have this particular property, and same property we can use here also. But we need to convert this into this form first, right? So here it is 2n, not x. So it should be n here, right? Not 2n. So we need to convert this 2n into this particular form. So what I can say, just say 2n equals to x. Now n will be x by 2, right? Now just try to put this in this particular limit. So limit x tends to infinity 1 minus what is 1 by n. So what is n? That is x by 2, right? What is 2n? That is x. I can simplify this limit x tends to infinity, 1 minus 2x to the power x, right? Now this expression is similar. Only difference is that the value of a in this case is minus 2, right? Now the output will be e to the power a, that is e to the power minus 2. Simple. If you remember this property, then this solving this type of expression is very easy. Okay, so answer will be option B. But if you don't know this property, then you need to solve by conventional method. So what is conventional method? Whenever you get this type of equation, that is 1 tends to infinity form. Okay, so if I just put infinity here, so what you will get, 1 minus 1 by infinity is 0, so 1, right, to the power twice infinity, that is infinity, that is 1 to the power infinity. So this is basically indeterminate form. Indeterminate form. Okay, whenever you get 1 is to infinity, or 0 is to infinity, or infinity tends to infinity, in all three cases what you have to do, consider y equals to f of x. So in this case n, that is 1 minus 1 by n to the power 2n. Right, now take log on both the side. Take log on both the side, right? Now you can bring this 2n down, so what you will get, 2n log of 1 minus 1 by n here, right? Now you can convert this expression into 0 by 0 form or infinity by infinity form. Okay, so this is the conventional way to solve this type of expression. Whenever you are getting 1 tends to infinity, or 0 tends to infinity, or infinity tends to infinity. Okay, so this is the way to solve this type of question. So take the log on the both the side, bring this expression down, bring this power down, and then take the limit. Okay, so I can write this equation as log of 1 minus 1 by n, that is 2, and basically 1 by n, right? So I can write like this. So if I take the limit n tends to infinity, so in this case it will be 0 by 0 form, right? If I just apply limit n tends to infinity, in this case it will 0 by 0 form. So I have converted this 1 tends to infinity into 0 by 0 form, and now you can apply L'Hospital rule. Take the derivative of this denominator, take the derivative of this numerator, denominator and numerator respectively, right? So that's it. Same thing we have to do. But better way to keep remember this particular property. Otherwise, it will take a lot of time to solve this type of question. Okay. So if you know the property, you can save your time. That's it. Otherwise, this is a conventional method. Okay. If you want, if you want an entire tutorial based on this type of indeterminate form, please comment below. I can record one tutorial for that also. Okay. Now, question number 10. So last question. Okay. So we have a function limit x tends to pi by 2. Okay, then we have 1 minus sine x into tan of x, right? Now just put the limit, what you are getting, 1 minus sine of pi by 2 into tan of pi by 2. So what does this indicate? So 1 minus sine pi by 2 is 1 minus 1, so sine pi by 2 is 1, so 1 minus 1 is 0, right? And this tan pi by 2, sorry, tan is pi by 2, so tan pi by 2 is does not define, is not defined, right? Tan pi by 2 is not defined. Or also what you can do, you can just simplify this type of expression, right? So what you can do, limit x tends to pi by 2, okay, 1 minus sine x. So cot x can be what? It is cot x, right? 1 by tan x is cot x, right? Now if I put this, right? Now if I put the limit, what I am getting? So 1 minus sine pi by 2 upon cot pi by 2. So basically 1 minus 1 is 0 and quad pi by 2 is 0. So this all 0 by 0 form. Now you can apply the L'Hospital rule. Just take the derivative. So limit x tends to pi by 2, 1 minus sine x. So that is derivative of 1 is 0, minus sine x is basically a cos x. So minus cos x, right? And what about cot x derivative? That is minus cos x square x, right? Now just try to put minus minus will get cancelled. So limit x tends to pi by 2, just put cos pi by 2 divided by cosec square pi by 2. Now this cos pi by 2, that is basically a 0, Now what is cosec square pi by 2? That is basically a 1. So 0 by 1 is 0. So answer will be 1, right? Right? So 0 is the answer. So this type of things also you can follow. But to solve all the types of question, limit question, you should know all the trigonometric function properties, trigonometric functions you should know, properties you should know. Okay, you must have learned this in 11 and 12. So very important, like what I have done here right just now. And also you should know derivative, how to find the derivative. So each and everything you have learned in the class 12th or in your first year, second year also. But this is the basic things for to solve any type of limit questions. So trigonometric functions, properties, and derivative you need to remember. You can just go through this one. So just take the standard trigonometric functions, the properties, and the derivative. Just the standard one, and how to take the derivative. So that will be enough. Okay. So that's it from this particular tutorial. Thank you.